Good morning, students. Exercise 1.2, the problem number 1, fourth subdivision. Let A be the set consisting of all the female members of a family. The relation are defined by A is related to B if A is not a sister of B. See that here the set A is given. So on the set, it consists of all the female members of a family. Only female members we have taken in that set. Or the relation R is defined by A is related to B if A is not a sister of B. So A is not a sister of B now, we can say A is related to B. So first we will see the reflexive. Reflexive means what? For all the elements from the set, the element is related to itself. Okay, so here the set having the female members of a family. So I'll take one family here. So what is that? Anita, Varsha, Deepa, Gayatri. Okay, so Anita and Varsha are sisters. I have taken like this. Deepa is a mother and Gayatri is a auntie in that family. So see now. Here, Anita, if you consider, Anita is a sister of Varsha, Varsha is a sister of Anita. But if you consider Anita, Anita is not a sister of herself. Or if you consider Deepa, Deepa is not a sister of herself. So a woman is not a sister of herself. Okay, so for all the members from the family, so I have written for all A belongs to A. That means A is the set. Okay, small a means it's a element in the set. Here, if you consider the female members, all the female members from the set, a woman is not a sister of herself. So A is not a sister of A. So A is not a sister of A. Now we can very well say A is related to A. So therefore R is reflexive. Next we are moving to the symmetry. Symmetry means what you have to say. If you consider A is not a sister of B, we have to check B is not a sister of A. So if we have, we can say the relation is symmetric. So you see that from the set A Anita is not a sister of Deepa. Okay, if it's so, Deepa definitely is not a sister of Anita. If you consider any other combination, Anita is not a sister of Gayatri means Gayatri is her aunt. So Gayatri cannot be a sister of Anita. Okay, so you consider Varsha and Deepa. Varsha is not a sister of Deepa because Deepa is her mother. So Deepa is not a sister of Varsha. So A is not a sister of B implies B is not a sister of A for that set. So A is not a sister of B means what? A is related to B. So what we got here, B is not a sister of A. So B is related to A. So if A is related to B, then B is related to A. So if the condition is satisfied, R is symmetric. Next we are moving to the transitive. Transitive, we have to take two conditions. What is it? A is not a sister of B and B is not a sister of C. So what we have to check? Whether A is a sister of C or A is not a sister of C. According to that, we have to conclude the transitive. So for example, Anita is not a sister of Deepa. Anita is not a sister of Deepa. Okay, Deepa. Deepa is not a sister of Varsha if we consider. Okay, so see now Anita, if you consider it as A and Deepa is B. Okay, so here I have written Deepa, so it is B and Varsha is C. Okay, so here I have written A is not a sister of B. So I have taken A is related to B according to this problem. and B is not a sister of Varsha. B is not a sister of C. So we have taken one more. B is related to C. These two conditions I have taken. What you have to compare? You have to compare A and C. Look at A and C. Anita is a sister of Varsha. So if we consider these two for the given set capital A, we may get A is a sister of C. You are getting for this combination. You are getting A is a sister of B. But here two elements are related means we have to get A is not the sister of B, okay, or C. Okay, so here we have considered A is not a sister of B and B is not a sister of C. So what we got? We got A is a sister of C. Okay, so here A is related to B and B is related to C, but A is not related to C. Here we are getting A is a sister of C, there is a chances there. So therefore A is not related to C. If it's so, we can very well say R is not transitive. So next problem we are moving, that is the fifth subdivision. On the set of natural numbers, the relation are defined by x is related to y if x plus 2y is equal to 1. Okay, so here what is a set? It is a set of natural numbers. So we'll take it as n. N is a set of natural numbers. Here what is the relation defined? X is related to y means x plus 2y is equal to 1. So if the natural numbers x and y satisfies this condition, so those x and y are in that relation. Okay, you take the relation x plus 2y is equal to 1. Okay, so we have to list out all the pairs in the what is that in the relation. So what is the condition here? It is x plus 2y is equal to 1. Okay, x and y are what? Natural number. So if I substitute, put x is equal to 1 here, x equal to 1, if I substitute 1 plus 2y is equal to 1. So what is your 2y? 2y is equal to 1. If you take it to the right side, it is 1 minus 1, that is 0. So 2y is equal to 0. So y is equal to 0 by 2, 0. 0, it's not a natural number. Okay, so see now, put the next natural number x is equal to 2. Okay, so 2 plus, in the place of x I have substituted 2. 2 plus 2y is equal to 1. Okay, so 2y is what? 1 minus 2. So 1 minus 2 means it is minus 1. So 2y. So y is equal to what? Minus 1 by 2. So minus, and it is in the fraction, so it is not a natural number. Okay, look at this. Here the condition x plus 2y is equal to 1. So the natural number, minimum number is 1. Okay, so if you consider next consecutive natural numbers, if you consider everything is greater than 1. Okay, here x க்கு நீங்கள் வேல்யூஸ் கொடுக்கும் போது எப்படி இருக்கும்? 1 கொடுத்துட்டேன், அது y வந்து 0. So next, if you give the natural numbers, all those numbers are greater than 1. So when you take it to the right side, here the number is 1. When you take it to the right side, okay, so those numbers are greater than 1 means you will get the negative value for y. So no pairs, no elements, no natural number satisfies this condition. So here in this relation is a empty set. No ordered pair satisfy this condition. Okay, so R in that relation, it's a empty set. So now what you have to show, this empty set, we have to check is it reflexive, symmetric, transitive. Okay, first we'll go for reflexive. Reflexive means what? All the elements from the set. So the set is a natural number. Okay, so if you consider the first natural number 1, so what we have to show if it is reflexive, 1 is related to 1. Okay, so here it's the relation is a empty set, so we can't write 1 comma 1, or 1 is related to 1, 2 is related to 2, or 3 is related to 3. That is 1 comma 1 does not belongs to the R because it's a empty set. So we'll say R is not reflexive. So that's why I have written for all x belongs to n. That means for all the natural numbers, the ordered pair x comma x. If you write the ordered pair x comma x means what? X is related to x. It does not belong to R. Why? In this R it's a empty set. So therefore R is not reflexive. Next we are moving to the symmetric. Symmetric means what? You should have the ordered pair A comma B belongs to R. So or ordered pair, that is A is related to B means we have to show that B is related to A. Okay, here it's a empty set. We don't have any pair. But we are going to show that it is not symmetric. Okay, so see that R is not symmetric means for the ordered pair x comma y belongs to R, we have to show y comma x does not belongs to R. So if you show like this, we can say R is not symmetric. You see that here R is a empty set. So we can't find a pair x comma y in R such that y comma x does not belongs to R. Okay, so இந்த மாதிரி நம்மளால ப்ரூவ் பண்ண முடியல. So we can't say R is not symmetric. So R is not symmetric is not true. So that's why it is R is symmetric. In the same way, we'll go for transitive. For transitive, what you have to do? You have to get two order pair. X comma y belongs to R and y comma z belongs to R. What we have to get? If x comma z does not belongs to R means we can very well say R is not transitive. R is not transitive. Here in your problem R is a empty set, so we can't find two pairs x comma y and y comma z in R such that x comma z does not belongs to R அப்படின்னு நம்மளால ப்ரூவ் பண்ண முடியாது. So our conclusion is R is not transitive அப்படின்னு நம்மளால சொல்ல முடியாது. So R is not transitive is not true. So therefore R is transitive. So therefore the empty set is not reflexive but it is symmetric and transitive. So we'll go to the fourth problem of that exercise 1.2. Let P be the set of all triangles in a plane. The set name is P. So P is the set of all triangles in a plane. And R be the relation defined on P as A is related to B if A is similar to B. So prove that R is an equivalence relation. So equivalence relation means the relation should be reflexive, symmetric and transitive. Here what is the set given? Set name is P. It's a set of all triangles in a plane. So all the triangles will be in the set. Okay, so what is the relation defined in this problem? A is related to B means A is similar to B. If any triangle is similar to another triangle, we can say those triangles are related. Okay, first we'll go for reflexive. So any triangle, if you consider, it is similar to itself. But for example, if you consider this triangle, right angle triangle, okay, it is similar to itself, we can very well say. So therefore for all the elements from the set, what is the set? Set is P. What is A? The elements. Here I have denoted the symbol for all. So for all the elements from the set, that element is related to itself. That is, A is similar to A. So therefore R is reflexive. Next we have to go to symmetric. Symmetric, what you have to do? You have to consider the one triangle. Okay, so this is your A, and you'll take the another triangle which is similar to A, so it is B. So now we'll say A is similar to B. A is similar to B. Okay, if we consider, definitely B is similar to A. Yes or no? So therefore we consider A is similar to B, so obviously B is similar to A. So if it's so, A is related to B implies B is related to A. So therefore this relation is symmetric. Next one we have to take A is similar to B. For transitive, we have to take two conditions. A is similar to B and B is similar to C. Suppose if we are having B is similar to C. Okay, then we can very well say A is similar to C. Okay, so from this, A is similar to B and B is similar to C are considered. We can very well say that A is similar to C. Okay, A is similar to C, B means what? A is related to B. B is similar to C means B is related to C. If you consider these two, here what we can say? We can say that A is similar to C. A is similar to C means, according to this problem, A is related to C. So the transitive condition is satisfied. So this relation is transitive. So we have proved it is reflexive, symmetric, transitive. So therefore it's an equivalence relation. Thank you, students.